In this video, I hope to actually link stress intensity factor, principal stress, and von Mises stress together. Alright, since you know, and also to touch on toughness itself. Alright, because I actually didn't talk much on toughness, and the definitions that I give you is not very adequate, and therefore, if it's a brittle toughness, alright, you're gonna have a curve something like that. Alright, and brittle toughness is somewhat talk about cracks. Alright, and talk about principal stress. Alright, talk about, so therefore brittle and cracks linked to principal stress, which is what we have found in the previous two videos where we talk about fracture toughness in terms of brittleness. Alright, now we're going to talk about toughness in terms of ductility. Alright, I'm not going to talk about it, but I just want to show you that this is just the ductility toughness curve. Alright, this whole thing, in fact, is the stress strain curve holding. The holding of the stress strain curve is talking about the toughness itself before it fracture over here. Alright, if you were to go to our graph, and it somewhat relates to this fracture point, and in fact the whole chunk of this will be somewhat the fracture toughness, because it's a measurement of how tough can you tahan all this stuff before you become fracture, or something like that. And for ductile toughness fractures, instead of using principal stress, we use the von Mises stress, and therefore we are talking about ductiles. For ductility, we use von Mises stress, and therefore, in order to determine what is considered a brittle or what is considered a ductile, and the magnitude of being safe or not, alright, the magnitude of being safe or not, we use the stress intensity factor. So, for example, if you know that this crack is allowable, is the last stand crack, any crack that is more than this will fail. So when you apply a certain stress, alright, as we have learned in the previous video on stress intensity factor, you know that you can calculate that the crack itself may be somewhere here, and this value is, or in fact the stress intensity factor of that particular, of maybe perhaps this particular crack, alright, compared to this one. What I mean, our stress intensity factor give you a gauge of whether do you cross the line. Have you crossed the line? Alright, this one is capped at maybe 25 MPa square meter, right? If you are more than that, this means that you fail. So stress intensity factor give you a certain numbers to compare with this. Alright, this is the fracture toughness of the material itself, you were to say. Alright, and as for von Mises stresses, it's also the same thing. If you go past this von Mises stress, alright, you're gonna calculate using a certain formula. Not place it over here, but once you get maybe a certain number, maybe 50 MPa or whatsoever, some values, alright, if you get this value, if your stress intensity factor with regards to this von Mises example, right, you would actually exceed 50 MPa, and therefore you're not good. Right, so the stress intensity factor gives you the gauge of a number to compare with to the maximum that you can allow. Alright, and therefore this actually links stress intensity factor, principal stress, and von Mises stress all together, and these are all the stress criteria. These are all the stress criteria, and therefore I hope that this gives you a good understanding. See you soon.